Inter versus intramolecular forces. An intermolecular force, as shown down here, it's a force that attracts molecules to one another. The weakest one will be London dispersion. We have this molecule here doesn't have a dipole, this one here doesn't have a real dipole, so they have close enough proximity, though, enough to have some sort of attraction. So it's quite weak, and hence why it's on the bottom of the ladder. We have dipole, next dipole-induced. So dipole is going to be a polar, so we have a dipole here. Induce is going to be a non-polar. As you can see, there is a force of attraction, slightly more positive to a slightly more negative side, because that's why this vector is shown here. In contrast, London dispersion doesn't have that, because neither of these have a dipole. Next, we have an ion-induced. It's when you have an ion that can polarize. So this is the ion. This one is a induced, so it's a non-polar, but this is going to be the one doing the polarizing, hence why we have that vector shown there. It's getting a little bit stronger as we go up. Next, we have dipole-dipole. We have two clear dipoles here, and both of them are attracted to each other. This side's more negative, this side's slightly more positive, so it's going to go in that direction, and you have a force of attraction that is quite strong. Next, we have hydrogen bonding. Hydrogen, we have it down here. Oxygen, we have it there. Oxygen is an example of a central atom that is quite electronegative and has a smaller atomic radii for this to happen, to create this strong electronegativity difference. Next, we have ion-dipole. You have an ion, then you have a dipole, and as you can see, the vectors is going from a slightly more positive to a slightly more negative side. It is by far the strongest. Next, we have intramolecular forces, as shown down here. It's force of bonding atoms to one another within the molecule. Metallic is by far the weakest. It's when the positive ions are free floating in the sea. Next, we have a covalent. It's when the electrons are specifically shared within the bonds and have a specific direction, as opposed to ionic, which does not have sharing of the electrons, but rather the ions are strongly attracted to one another and they're giving away electrons from one ion to the next. In order to figure out type of intermolecular force is going to be exhibited in a segment. Well, are there any ions involved? If there are no ions involved, determine if it's polar. If it's not polar, it's going to be LD, London dispersion. If it is polar and it goes through HNOF, it's going to be an H bond, hydrogen bonding. If it doesn't go through HNOF, it's going to be dipole, or it's going to be dipole-induced. So I'm going to put dipole, IND. Next, we have up here, yes, ions involved. Then we're going to put polar and ions. If polar and ions are in play, then it's going to be an ion dipole. But if it's not, then it's just going to be an ion induced.